State space analysis is another approach to assess the stability of the system. Most of the time, the transfer function concept or transfer function approach is being used to assess the stability of the system, but transfer function has got some limitations. It is applied only to single input, single output system, and this can be applied only to the linear system, and it can be applied to time invariant system, and most important, initial conditions are ignored. The definition of the transfer function says the ratio of Laplace transform of output to the input. The transfer function says, but initial conditions are ignored. Ignored initial conditions. So, all these disadvantages can overcome that state space analysis can be used to multiple input and multiple output system. This can be extended to nonlinear system, and it can be for time variant system, and initial conditions are not ignored. So, initial conditions are considered. So, that is the advantage of state space analysis. We can use for multiple input, multiple output system and all. The definition of the state is, or it gives the future behavior of the system, based on present input, and past history of the system. So, when I say the state is nothing but future behavior of the system, then this is divided into two. One is present input. The system is excited at present input, and the other one is the past history. So, what is the meaning of past history of the system? If you take an electrical engineering, past history means there must be an energy storage elements. That means an inductor and capacitor must be there, memory elements or energy storage elements must be there in that, and initial conditions. That's nothing but past history, nothing but initial conditions are to be considered. This initial conditions is nothing but when you consider an inductor in the system, what is the current through the inductor prior to the present input? That is called past history. And what is the voltage across the capacitor before? That means that is also the past history. So, memory is nothing but energy storage. That elements, if they are existing in the system, then the inductor and capacitor, current through inductor and capacitor voltage are considered as state variables of the system. When you consider the simple example, a potential divider network with some input voltage, say 10 volts is applied, that is equal to Vi, say this is 1 ohm and this is also 1 ohm, and output voltage V0 across these terminals, V0 is equal to 5 volts. It is a potential divider network, and this network is actually called as a memoryless system. Memoryless system is nothing but there are no energy storage elements. There are no energy storage elements like L and C are not there. That's why it is called memoryless system. And resistor is an energy absorbing element, so it cannot store energy. That's why state space analysis need not be applied to this memoryless system, because it doesn't have any past history. Past history will not be there in the case of resistor case. That's why it is called a memoryless system. So state space analysis can be applied when there is an inductor and capacitor in the system. So the number of state variables present in the system depends on what? If it is an electrical system. So the number of state variables of an electrical system is equal to sum of inductors and capacitors. So this is the case to know the number of state variables if electrical network is given or electrical system is given, and if differential equation is given, the system is described by its differential equation, then the highest order, the order of the system, equal to number of state variables. A system is described by its differential equation, then the number of state variables equal to the order of the system or order of the equation. And the standard form of state model is given by x dot is equal to ax plus bu, known as state equation, and y is equal to cx plus du, this is known as output equation. So together state equation and output equation known as state model. So in this, what is x? X is known as state vector. The state of the system is known by this state vector, and u is input vector, and y is output vector, and x dot is differential state vector. X dot is differential state vector, and A is a state matrix. And B is input matrix. And D is transmission matrix. transmission matrix and C is output matrix. So when you look at the state model, this x dot, x, u and y are the vectors and A, B, C, D are the matrices. So any system can be described. It may be a linear system or non-linear system. It can be described by the state model. Like we have a transfer function for the analysis of the stability and all. We need to have a state model. Any system must be described by the state model, which consists of all these vectors and all these matrices, so that analysis can be done. So the state model, it consists of 4 matrices A, B, C, D and state vector, differential state vector, then input vector and then output vector. So as this state space analysis is applied to the multiple input and multiple output system, I want to know the order of the matrices and the dimension of the vectors, dimension of the state vector, input vector and output vector. So generally the multiple input, multiple output system, it is called as MIMO, multiple input and multiple output system. It has multiple inputs. That means it is not single input, but there are multiple inputs. It starts from U1, U2, U3 and so on up to UM. So this is called multiple inputs and it has got an outputs also multiple outputs Y1, Y2, Y3 and so on YP. So it has got P outputs. This is called multiple input and multiple output system. And the very important is the state variables. This system has got some energy storage elements. If you consider it as an electrical system, then there will be state variables starting from x1, x2, x3 and so on x power n. So this system may have n state variables, n state variables. With this, I will be knowing the dimension of the input, output and state vectors. So input vector is given by U1, U2 and so on up to UM. So the dimension of this vector is m cross 1, m rows and 1 column. Now output vector has got y1, y2 and so on yp. So the size or dimension of this vector is p cross 1. Next, state vector, number of state variables are n. So the state vector is x1, x2 and so on xn, and the dimension of this vector is n cross 1. So 3 vectors are given. Of course, differential state vector is x1 dot, x2 dot, so on xn dot. That means this also has got n cross 1. Like a state vector, the dimension of the differential state vector also n cross 1, where n is number of state variables of the system, is nothing but the number of energy storage elements present in the electrical system. Now coming to the order of the matrices. The order of the matrices. To know the order of the matrices of the state model, which is given by x dot equal to ax plus bu state equation. So this x dot has got a dimension of n cross 1, where n is number of state variables, like x. X is also a state vector. Both have same dimensions. Now this A dimension, A matrix is a state matrix. So n cross n, the dimension of A matrix is n cross n, whereas B is known as input matrix. So number of state variables n cross m, where m is number of input variables. So the dimension of B matrix is n cross m, and in the output equation y is equal to cx plus du. So this C is known as output matrix. So the dimension of this is P cross n, and the dimension of D is P cross m. These are the 4 matrices. So this U is the input vector, it has got m cross 1, and Y is the output vector, it has got P cross 1, and U is again m cross 1, and state vector is n cross 1. So all the vectors which has got either m cross 1, n cross 1 or p cross 1, but matrices have A matrix, you can see the dimension is n cross n, that matrix is known as state matrix, and B is known as input matrix, which has got n cross m, and C is the output matrix, that's why it has got P cross n, where P is number of output variables, and D is known as transmission matrix. So P is output and m is input variables. So transmission matrix has got P cross m dimension.